Okay, here's a subnetting example problem. And what it asks is, it gives you an IP address, and it gives you the subnet mask, and it says, what subnet is this packet on? Okay? And what we're going to do is we're going to note, first of all, that with a 192 in the first byte, that implies a Class C network. It happens to be a private Class C because it's 192.168. And a Class C network has 24 network bits. In other words, the first 3 octets describe the network. Okay? That's before subnetting. Now we've subnetted it. And we've subnetted it, and you can see that the subnet mask is not 255.255.255.0, which would mean that n was 24, but instead it has a 224 here. And 224 is one of those special numbers that we often see in subnet masks, because 224 is 128 plus 64 plus 32. 128 plus 64 is 192, 8 to 224 more from the 32 to 224. And so 224 in binary looks like 11100000 in base 2. And we can see that here's the 128's place, here's the 64's place, and here's the 32's place. Okay? And we just double check real quick. 1, 2, 4, 1, 2, 4, 8, 16, 32, 64, 128. Good. Okay? And so what this means is that the first 3 bits of what was H equal 8 and 256 host addresses, or 256 IP addresses, or less host addresses, instead of having H is 8 and 256 IPs, instead we have H is equal to 5 and S is equal to 3. Well, the number of ones in the mask is equal to n plus s. And with n equal 24, well, the number is here 8 plus 8 plus 8 for the first 3 octets, the 255s, those are all ones, plus the 3 that we got here. And this is 24 plus 3, or 27. Okay? And if n plus s is 27 and n is 24, that implies now that s is equal to 3. Okay? And so, therefore, H is now, with subnetting, 5, and we have the number of subnets is 2 to the s, 2 cubed, or 8, and the number of IPs per subnet is equal to 2 to the h, which is 2 to the 5th, which is 32. And of course, we've now taken our 256 and divided that up into 8 times 32. Okay? 2 to the 8th, or 256, is 2 to the 3rd times 2 to the 5th. Okay? So we've divided up into 8 subnets, each of size 32. And now it's a straightforward thing to figure out what's going on here. I don't know exactly what that little guy is there. And we can now write down the subnet ranges and see which subnet is containing our IP address. Here's the subnet IDs, the first IP in the subnet, the last IP in the subnet, and the broadcast IP in the subnet. And we're going to start at 192.168.10, and we're going to start at 0. And because there are 32 per subnet, we're simply going to count by 32s. 32, 64, 96, 128, 160, 192, 224, and 224 plus 32 is 256, so that's it. And so the first IP is .1, .33, .65, .95, .127, .161, .193, .225, and the broadcast IPs are then one less than the ID, the network ID for the next one up. So we got the 32.31 for that, the 64.63, 96.95, etc. .127, .159, .191, .223, and .255 is always that last one. And then the last IP is one less than the broadcast, .30, .62, .94, .126, .158, .190, .222, and .254. And now we can look at this list of the subnets that we've created. So these are all the subnets that are in this 192.168.10, and 115 is in one of these. And let's see, 115 is in the range from 95 to 126. So 115 is here. Okay, and if we are to, and so the subnet for 192.168.10.115 is 192.168.10.96 is the ID for that subnet. Okay, and basically all we're doing is figuring out that, hey, with a 224 subnet mask on a Class C network, that means we have 3 bits at the beginning, which means we have 8 subnets, which means we have 32 IPs per subnet, and we're going to count by 32s and see which chunk of 32 the 115 is in, and it's in the one that starts at 96 and goes to 127. Okay, so that's how you do this problem. And another way of looking at this same thing is to simply take an AND on the binary. So take the IP address and AND it bitwise with the subnet mask, and it's going to give you the network ID. Let's do that real quick. 115 is 64 plus 32, which is 96. We got 19 more, so we got a 16, and 3 more is 2 and 1. So 115 is 0 in the 128's place, 1 in the 64s, 1 in the 32s, 1 in the 16s, 0 in the 8s, 0 in the 4, 1 in the 2, 1 in the 1. There's 115. And 224 we already figured out. Is that it? It's a 224, right? Yep, 224. Oh, great. And 224 we already figured out is 1, 1, 1, 0, 0, 0, 0, 0. Okay? Now if we're going to AND those bitwise, what we're going to do is we're going to look at the 0 and the 1, and we get a 0. Only when we have 2 1s in the bitwise positions do we get a 1. Otherwise we get a 0. And so we're going to get a 0, 1, 1, 0, 0, 0, 0, 0. And this number is 64 plus 32. 64's place, 32's place, and this is the 96. And that's the same answer we get above when we just look at the multiples of 32. Okay? And so the subnet ID is 192.168.10.96. Okay, that's another way of looking at the same problem. There's two different solutions that both work equally well, and I hope this helps.